Okay, students, let's do our work-energy theorem problem. So this one is a car that's on the highway and it's traveling at 29 meters per second, and then it comes to a stop. It stops in 75 meters and we want to find out what is the force required to do that. So what we'll do is, just like any of the other problems, we're going to list all the information. So the mass for this car is 1,000 kilograms. The car is initially moving at 29 meters per second, and then it comes to a stop. Final velocity is 0. And it does that, we said, in 75 meters, and we want to find what is the force required to do this. So there's a number of ways that you can solve this problem, but because it is the work-energy theorem, or the work-kinetic energy theorem, that's what I'm going to do to solve this problem. That's what I'm going to use. So work equals change in kinetic energy. So anytime we have that delta, we want to expand it. Final minus initial, no different here. So this is work equals kinetic energy final minus kinetic energy initial. Now what we need to do is we need to do a little bit of substitution. So work equals FD. So any place that I see a work, I'm going to take this and put that in over here. I'm going to do the same thing with kinetic energy. Kinetic energy is 1/2 mv squared. So any place that I see kinetic energy, I'm going to take this and put that in over here and over here. So I have two substitutions for this one. So on this side, I end up with FD equals, I have my kinetic energy final, so I'm going to write 1/2 mv final squared. And then I have my kinetic energy initial, so I'm going to write 1/2 mv initial squared. Now, the nice thing about this problem is that it shows us that we have a final velocity of 0. So that means that this whole term right here can be canceled, because if our final velocity is 0, then it doesn't matter what the mass is. This just goes away. Let me rewrite what I have. I have FD equals minus 1/2 mv initial squared. And the only thing I have to do now is divide both sides by distance so that I can solve for force. So I will do that. We can see that it cancels over here. F equals, I still have that minus. I have mv initial squared over 2 times my distance. So this is the equation that solves this practice problem. You might be thinking, well, what about the 1/2? Well, it's right here. Right here is the 2 and the 1/2. The 1 is up here, but remember, we don't write a 1 in front of the variables. So from this equation, I can just input all of my numbers, right, these measurements. So I've got my 1,000 kilogram mass. Don't forget the minus. We're moving initially at 29 meters per second squared, divided by 2 times our stopping distance, which is 75 meters. And when we put this into the handy dandy calculator, we end up with negative 561 newtons of force to stop this car. So there you have it. That is one sample problem for using the work-energy theorem. Also remember, this is really Newton's second law. F equals ma. It's just hidden in disguise. I will see you in class.